All right, so the probability of none of them having it really is kind of like a intersection of quite events. That means the first swimming pool or swimming hole has to be E. coli free. So let's see, what notation do we want to use for this? E. coli free at the first swimming pool, and E. coli free at the second one, and so on, all the way down the line. E. coli free at the sixth one. So now we're looking for the probability of all 6 of these events happening at the same time, a multiplication. Well, here's where something else we've discussed about probability is going to come into play. Does the probability that the first swimming hole has E. coli influence in any way that the second swimming hole has E. coli? No. So what's that allow us to do here? They're independent. That's the good buzzword. So this is going to be 1 minus the probability that the first one is E. coli free times the probability that the second one is E. coli free, all the way down to the sixth one, E. coli free. Well, what is that probability? What's the probability that a particular swimming hole is not going to have E. coli? They give that to you. All right, be careful. Remember, we're trying to find, what's that 2% reflect? The 2% reflects 0.02. But what does it mean? What does the 2% signify? The percent chance of having E. coli. But we want the percent chance of them not having E. coli. So what's that percent chance? 98. So basically it's 1 minus 0.98 to the 6th power. And hopefully you can do that on your calculators. You should get, well, I'm going to let you find it out before I put it up on the board. Make sure that you can find that, though. If you're having trouble figuring out how to do that on your calculator, let me know. Scott and I will walk around and help you out if you need some. You should see a little up arrow button on the right side of your calculator, right above the division key, that allows you to raise something to a power. So do 1 minus 0.98 raised to the 6th power. 1 minus 0.98 raised 6 should be
0.21.
Yeah, I think I get something similar, 0.1141. Yeah, so about 0.1142. Generally speaking, I'm going to want 4 significant digits from you when you give me a probability. I'll try and remind you of that on a test. All right. Questions on number 20? Yes?
On the top, you said that the complementary is probability of 0. Like 1 minus probability of 0.
Good.
So why are we doing on the bottom using the words at least 1?
We didn't do that probably. I mean, I just described this event, or actually Steve described it as saying that the probability of finding E. coli is this: the probability that at least one of the pools had E. coli. Okay, so it gave you a description of what could happen in terms of finding E. coli. Now, the complement of that event is that none of the pools have E. coli. And it was easier to calculate this one probability than it would be to calculate these 6 probabilities. So that's why we chose to use the complement. Well, this probability of finding E. coli, is the probability of at least one of the pools having E. coli. Now, the way you calculate this probability is up to you. You could calculate it directly, like this, or, like we did, we could use the complement. Do 1 minus the probability that none of them have E. coli. And that's going to be the same probability, but it's going to be a much easier calculation. So we calculated it, instead of calculating it directly, which would be this, at least 1, we calculated it using the complement, which is probability of 0.
What would that be if I do at least?
That'd be a lot of work, because you would have to go through and calculate the probability of 1 plus the probability of 2. You'd have to calculate all of these, and quite honestly, we don't have enough machinery yet in our tools to calculate some of these probabilities. It goes beyond what you know at this point. So we couldn't do it this way, knowing what you know, even if we wanted to. It would just be too much going on with that one. So you're kind of forced into doing it this way. And then actually, you'd probably want to do it this way, even if you could do it this way. This is just a lot more work here to try and do it this way. Okay, problem 12. Probability of at least one girl. If a couple plans to have 10 children, what is the probability that there will be at least one girl? If the couple eventually has 10 children and they are all boys, what can the couple conclude? All right, well, let's first of all work on the probability of at least one girl. And again, let's draw the sample space, all the different things that can happen, and let's list the number of girls among 10 children. What numbers should I list here? What could be our sample space? Good. 0 through 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we're asked to calculate the probability of at least one girl. Well, what events satisfy that criteria of at least one girl? 1 through 10. This is at least one girl. So if you wanted to calculate that probability of at least one girl, then it'd be the probability of 1 or 2 or 3. Wow, there's got to be a better way. Good. Thanks, Raj. We're going to use the complement. Okay? Instead of calculating this probability, which would be kind of a pain, we're going to focus on the complement. So, what's the complement of at least one? 0. So we can calculate this probability by calculating 1 minus the probability of 0. That is no girls. Well, let's step aside for a second and try and calculate what that means. Probability of 0 girls. Really means they're all boys, right? So we get a boy on the first one, and a boy on the second one, and so on, all the way down to boy on number 10. So we need to focus on this calculation. But as before, there's a key step here that we need to know. What helps us out here? Good. They're independent. So Johnny, what's this probability then? Just this one. What's the probability of a boy? 1? Just this one boy. What's the probability that the first birth you're going to get a boy? 1/2. 1/2. The probability of a boy, I mean, we're not going to work with the actual actuarial numbers that you can get from the CDC or someplace like that. We're just going to work with, a 50-50 chance, boy or girl. So probability of a boy is 1/2. 2 to the 10th is 1,024. Now that's the probability of 0 girls. So let's put that number back up here. 1 minus 1 over 1,024. Now I've kind of skipped this step a couple times. Let me put it in here just in case a refresher on some of your algebra would help. In order to subtract, you need common denominators. So let me write that as 1,024 over 1,024. So when you subtract the bottom line, you should end up with 1,023 over 1,024. 1,023 over 1,024. Yeah. Is the probability high enough for the couple to be very confident that they will get at least one girl? Oh, I was reading problem number 11. If the couple eventually has 10 children and they are all boys, what can the couple conclude? Yeah, they're really unlucky, or Dad's taking some special vitamins or something. Something's changing the probability here, because getting 10 girls, or for that matter 10 boys, would be really, really unlikely. I don't know. I got what they call the $1 million family: 1 boy, 1 girl. So I got lucky there. You have 8.
Oh yeah, I have 8 uncles and all from the same. Well, they're all.
There were 8 boys from your grandma, or yeah, wow. That would only happen 1 in 256 times. That's your grandmother must have been just like going, wow. Actually, there's a story that I can share with you real quick. One of my colleagues. Problem number 18. This is kind of like a replay of what we did earlier, but I just try and reinforce some of what we've done. With one method of the procedure called acceptance sampling, a sample of items is randomly selected without replacement, and the entire batch is rejected if there's at least one defect. If the MedTime company has just manufactured 5,000 blood pressure units and 4% are defective, we want to find the probability that the entire batch will be rejected. So I'm going to give you a couple minutes to do this on your own. Scott and I will walk around and try and help out. But see if you can't calculate the probability that if 3 are selected and tested, that you'll reject the entire batch. So in order to pass, All three of them have to pass. All right, good luck. If you have some questions, Scott and I will be walking around, trying to help each other out, trying to help you guys out.